This lesson is on finding all zeros. It's related to the fundamental theorem of algebra, if you've heard of that. So the first thing that we have to realize is what it means to have the degree of the function. Degree is the highest power of x. So you look at the x's in the problem and see which one has the highest power. Whatever that power is, that should equal the number of zeros it has. Now, that doesn't mean that they're all zeros where it crosses the x-axis. Some of them will have i's. And so it's not necessarily just real zeros. It's a mixture maybe sometimes of real and imaginary. Sometimes it is all real zeros. But we're going to be finding all of the ones that we can find with each polynomial. What we're going to be trying is factoring, because factoring is usually the easiest step, and so if it factors, that's a good way to solve. If it doesn't factor it, we're going to find it by graphing and finding x-intercepts. And then we're going to use synthetic division if we need to find any imaginary ones, and we may end up using the quadratic formula and things like that. So we have several examples of this, and we'll start with this first one here of f of x equals x squared minus 6x plus 9. So to find the zeros, I set the f of x equal to, so I just replace that f of x or y value with a 0, and then this one actually does factor very nicely to x minus 3 and x minus 3. So when I go to solve it, I set each one of those equal to 0. So x minus 3 equals 0 twice. If I add 3, I get x equals 3 in both cases. Now, I was supposed to have two answers because this is x squared, and I got two answers. They happen to be the same number. What that means is that this graph, this parabola, bounces off of the x-axis at 3. So if you get an answer twice, that means your graph is bouncing off of the x-axis. This one happens to face up because we know it's a positive coefficient in front of the x squared. So it should bounce off like this when I graph it in the calculator. But sometimes they're negatives and they bounce off facing downward, and that's fine. But two answers that are the same means that the graph bounces off. Okay, example 2. Again, I'm going to start by plugging 0 in for f of x, and this time I need how many answers? 3, because the highest power of x is 3, the degree of this polynomial is 3, I should get 3 zeros. This one, again, factors fairly easily. It has a GCF of x, so if I take out an x, I have x squared plus 4. And I can actually work this pretty much like I did the last one. I set the x equal to 0 and the x squared plus 4 equal to 0. X equals 0 is nice and already solved, so there's one of our answers. X squared plus 4, if I solve that, I'm going to subtract the 4, and then I'm going to take the square root. Whenever you're solving these types of equations and you take a square root, you want to make sure to consider the positive and the negative version when you're solving these types of things. Sometimes we just look at the positive, but this is one of the cases where we do look at both. And now that we've worked with i's and complex numbers, we know that this is a positive 2i and a negative 2i. And so that's a total of 3 answers, and we were supposed to have 3 answers. Now on the graph, what that means is this cubic function, we know the basic shape for a cube, it's going to pass through 0. 0 would show up as a 0 x-intercept type thing on your graph. But because you have i's as answers, what that means is like the hills and valleys that your graph has are going to be, in this case, above. Sometimes they're below the x-axis. And so imaginary answers just means that the humps and bumps show up, but they're above or below the x-axis, they don't cross over. This graph is not going to cross the x-axis anymore because these are imaginary numbers, complex numbers. It will only cross at 0, but all three of them are considered the zeros of this function. Okay, 3 would be a good one for you to try on your own. I will help you get started. If you want to pause now and try it, great. If you want to just keep listening, you can. But again, always start with setting it equal to 0. And this one will factor. You just have to remember that it's going to factor to x squareds in the fronts of the parentheses. Okay, so we have the x squareds in front, and then if you are doing your factoring, you have a negative 20. We're trying to get a negative 1. So that'll be a negative 5 and a positive 4. So you have x squared minus 5 and x squared plus 4. When you set those equal to 0, and you add 5, x squared would equal 5, and then when you take the square root, the x will equal the positive and negative square root of 5. So that's technically 2 answers, and again, we are supposed to have 4. So then I come over here, I subtract the 4, I get x squared equals negative 4, and again I take the square root, and in this case I'll get i's. So x will equal positive and negative 2i. So I have 2 answers that are real. These are places that the graph would cross the x-axis. And I have 2 that are imaginary, so there's some kind of hill and valley situation going on that does not cross the x-axis. So there's my 4 answers like I'm supposed to have. Okay, for this next one, you're going to need your calculator, because this one we're not going to be able to factor like we've been doing on the others. And so we're going to move to that other method of figuring this out. So what I would like for you to do is to go to a standard window, negative 10 to 10, and graph this polynomial. Okay, you should get something that resembles this. I mean, this is not perfect, but it should look on your calculator like it has a 0 right here and like it bounces off right here. So you can calculate this first one by doing second calculate 0, going on the left side, hitting enter, going on the right side, hitting enter, and calculating that. When I did it, I got negative 2. Now, please pay attention. When the graph bounces off like here, you can't do the 0 in your calculator because your calculator looks for a sign change from negative to positive or positive to negative, and obviously you're positive on each side here. So it's not going to calculate a 0, but you know also that that is the minimum. It's the bottom of a valley, so it's a minimum. Your calculator will calculate it as a minimum. And so if you do second calculate min, you will get that that x value is a positive 1. You should get the 0.10, and we just care about the x value for this. Okay, what this graph means is that I have negative 2, 1, and 1 as zeros. Out of my 5, I have found 3 of them. And again, I know that that 1 counts as 2 answers because that graph is bouncing off. I need to find the other 2. The other 2 are more than likely, or will be, imaginary numbers, because if they were real numbers, we would see this graph crossing the x-axis more times. So the others are i's. How we're going to get them is using synthetic division. So the zeros that you have, you're going to do synthetic division with your polynomial. So I'm going to take that negative 2 and list everything out. Notice you jump the 4th power here. So I'm going to have 1, 0, 1, 2, negative 12, and 8. And then I'm going to do synthetic division. So I'm going to bring down my 1, multiply and get negative 2, add and get negative 2, multiply and get 4, add and get 5, multiply and get negative 10, add and get negative 8, multiply and get 16, add and get 4, multiply and get -8, add and get 0, which means that it was a 0. We knew that already. We should have gotten a 0 here, and that's one of the zeros. Now, that took our problem from x to the 5th to x to the 4th, but I know 2 other zeros, so I'm going to do synthetic division again. And I can just tag that on right here and continue it with these numbers. So I'm going to leave my space. I'm going to bring the first one down. I get a 1, multiply and get a 1, add and get a -1, multiply and get -1, add and get 4, multiply and get 4, add and get -4, multiply and get -4, add and get 0. And again, I should get a 0 on the end because this was a 0 of the problem. Now I'm to the 3rd power, but I know another 0 to make the problem easier. So I'm going to take the 2nd one, and do synthetic division again. So bring down the 1, multiply, add, multiply, add, multiply, add. And I have went from the 5th power of the problem to the 4th to the 3rd. This should be a squared line. So I have x squared plus 0x plus 4, which is easier to write as just x squared plus 4. And I'm not sure why all of our problems ended up with this same thing, but you just solve it by setting it equal to 0. And this one I can subtract the 4 and take the square root, and we're familiar with this because we've done this one in the previous 2 problems. You get a positive and -2i. So I have 3 real zeros, -2, 1, and 1, and I have 2 imaginary zeros, a -2i, and a +2i. So there are my 5 answers for this problem. Okay, so let's move on to example 5. Example 5 is another one that there's not an easy way to start, so I want to start by graphing this and seeing if I have any real zeros. So graph this in Y1 of your calculator and calculate any zeros that you see. Now, if you're in a standard window, you see something about like this. You know that's not what the full graph looks like because x to the 4th is probably going to have some sort of W look to it, some kind of W shape, and we're just seeing part of it. And if you zoomed out, you could see the rest of it. But I don't have to zoom out. I'm not trying to find maxes and mins right now. I'm just trying to find zeros. So I can calculate these 2 zeros and work with them without having to see the full graph. So if you hit second calculate, you should get a 0 at -2 and a 0 at +3. So that is 2 of your answers for sure, and you're supposed to have 4, so we need 2 more. Again, the way that we get those is by getting rid of this extra stuff by doing synthetic division. So I'm going to put one of the zeros in the box, and I'm going to do synthetic division. So I have 1, -3, 6, 2, and -60. I'm going to bring down the 1, multiply and get 2, add and get -1, or excuse me, that was a -2, sorry. That changes things a little bit. So -5, multiplying and get a +10, add and get 16, multiply and get -32, add and get -30, multiply and get +60, which gives you a 0 on the end like it should. Then use your other 0 and do the next line. So I'm going to use the 3, bring down the 1, multiply and put the 3 under the next one, add and get a -2, multiply and get a -6, add to get 10, multiply to get 30, add to get 0. Okay, that leaves me with 1, -2, 10. this was x to the fourth, so our answer the first time was x to the third. This row is x squared, so I really have x squared minus 2x plus 10. Now you might have the question, what would have happened if I'd used the 3 first and then the negative 2? It wouldn't matter. You should get the same answer out because they're both zeros of this problem. So just whichever one you want to use first should work. At this point, you have to ask yourself, okay, can I factor? Probably not, or you would have seen that 0. So this is a quadratic that I can solve using the quadratic formula. I'm not going to be able to solve it graphically, or I would have seen it already. This has to be quadratic formula. So my A is going to be 1, my B is going to be negative 2, and my C is going to be 10. So x will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And then two negatives will make a positive. Negative 2 squared is a positive 4. 4 times 1 times 10 is 40. 2 times 1 is 2. 4 minus 40 would be a negative 36. And then negative 36 underneath the square root, we learned from our complex numbers lesson, would be a 6i. So 2 plus or minus 6i over 2. I can reduce these because 2 and 6 all have a 2 in common. And if I reduce them all by 2, I get 1 plus or minus 3i over 1, and we don't normally write fractions over 1. So I'm just going to write 1 plus or minus 3i. That is the other two answers, because 1 plus 3i is an answer and 1 minus 3i is an answer, and I have 4 answers that I'm supposed to get in this problem. Okay, now we want to be able to write an equation for a polynomial given the zeros, and it's really just kind of working backwards. But now that we know how to work with i's, we're definitely going to throw some i's in. Something about this, if they just gave you the polynomial had zeros of 3 and 1 plus I, you would know that it would also have a 0 of 1 minus I, because the conjugate will always be a 0. So, for example, if I had 2 minus 3i that I knew was a 0, even if they don't tell me, I know that 2 plus 3i is also a 0. And the same thing with square roots. If I knew 1 minus the square root of 5 was a 0, or 1 plus the square root of 5, 1 minus the square root of 5 would also be a 0. In this case, they've given us all three, but i's and square roots do come in pairs, conjugate pairs, because they come from the quadratic formula, and that always gives us a plus answer and a minus answer. What you need to be able to do here is back up from the zeros to the factors. So if you think about how we solved up there and got a 3 as an answer, it came from a factor of x minus 3. We solved that and we would get an answer of 3. And so what you did really to back it up is change the sign. Now, we didn't get i's that way, we got them from quadratic formula, but doing the quadratic formula backwards is a little bit impossible. So you just treat them the same way, you change the signs. So x, and then here you change the sign of the 1, so minus 1, and then you change this sign as well, so minus I. And then you do the other one the same way. Change the sign of the 1, so x minus 1, and change the sign of the I, so plus I. And so once you have everything backed up, you multiply it out. You can only multiply 2 parentheses at a time. And I'm just going to bring down the x minus 3 and save it till the end, because I think once I multiply these two out, a lot of things will cancel or combine. This will be not foiling, triple distributing. I need to take the x and multiply by everything in parentheses, the negative 1 and multiply by everything, and the negative I multiply by everything. So I should have 9 things listed out if I've done it correctly. So x times x is x squared. x times negative 1 is negative 1x. X times I is xi. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And negative 1 times I is negative 1 or negative I. Then negative I times everything. Negative I times x is negative xi. Negative I times negative 1 will be a positive I. Negative I times I would be a negative I squared. And again, we're going to be using that I squared thing that we did before. And this is why I wanted to multiply these out first, because a lot will cancel. You should notice that the positive xi and the negative xi will cancel. The negative I and the positive I will cancel. The other thing is, when you have I squared, you know it's a negative 1, so negative 1 is the same as plus 1. I can go ahead and think of it like that. So I have x squared. I have two negative x's, so negative 2x. And then I have 1 plus 1, which is 2. Then I'm going to distribute the x through and then distribute the 3 through and combine what I have left. So x times everything. X times x squared is x cubed. X times negative 2x is negative 2x squared. And x times 2 is 2x. Then negative 3. Negative 3 times x squared. Negative 3 times negative 2x. And negative 3 times 2. And then my final step is just combining anything I can. So I have negative 5x squared and 8x when I put those together. And so this would be my final answer, this polynomial, because we were writing the equation for a polynomial. And that concludes this lesson.